Hello, grade 6. Today we're looking at section 12.3, fraction and decimal equivalence. Today we're going to be focusing primarily on the fractions that are halves, so denominator 2, fractions that are fifths, denominator 5, and fractions that are tenths, denominator 10. Our numerators, the number of pieces, can be different types, whatever we need them to be. So let's take a look for a moment. We're going to start off with looking at, for example, 1/2. If we look at 1/2 here, I've just outlined 1/2. There are a number of different examples of how 1/2 can be written. So here we have our 1/2, but we can also write it as 2/4. So while this is 1/2, I can also rewrite it in an equivalent way as 2/4. And if I keep looking down my line here, the same area would be 3/6 right there. So 3/6 is also another way of writing an equivalent form of 1/2. Once again, equivalent does not mean the same, it means the same value. So keep that in mind while we are working on this particular section. Here we have a 100 grid, standard 100 grid, 10 columns, 10 rows, and we have a number of different ways of chopping up this grid to meet whatever our needs are. One of our needs could be, if we were to look at this piece right here, this is 1 out of our 100. So if I look at this one yellow piece, I can call that 1 out of 100. And why can I say that? Because we have highlighted one yellow piece out of a total of 100 pieces. So 1 is the yellow one, 100 is the total number of pieces from which we have to choose. And we can keep doing this in a few different ways. I might be able to take, let's say, this right here. So if I color them in this way, now I can call this 1, 2, 3, 4, 5. I can call it 5 out of 100. So I have 5 yellow pieces out of 100 yellow pieces. And of course, the same thing can be said for if I took a total of 10. So I'm highlighting now 10 total pieces. So by highlighting this many, I can now call this 10 out of 100. So we can use this to show any fraction out of 100. But we can also show these fractions in a different way. We don't always have to use the denominator of 100. Let's say, for example, instead of calling this 100 white squares, what if I was to divide it up this way? If I took this and I made groups of 10 of these 100s, of these ones, I would then have broken this up into tenths if I chose to do it this way. So by cutting them up in this manner, I now have exactly 10 groups. There are exactly 10 groups and they're all exactly the same size. So if I was to look at this and highlight one of these two like that, did all the highlighting here, I have highlighted what I said before as either 10 pieces out of 100. That's what I had previously. But right now, I highlighted one larger piece out of 10 of my smaller pieces. So I can also call it this, depending on how I want to look at this hundreds grid. So that's another way of looking at it. I can also draw this in a different way. I can cut them up into pieces of exactly 20. And if I cut them up this way, I have made exactly 5 groups, and each group is of the exact same size. For fractions, that is very important. The groups have to be the exact same size. So if I was to highlight, if I highlighted this piece right here, like that. Depending on what I wanted my denominator to be, I could call this either 1/5, and that would be if I take one of these large groups into consideration. I have 1, 2, 3, 4, 5 groups, and I've completely circled in one of them. That's 1/5. But I can also call it 2/10. That would be if I took one of these strips as a tenth. I have 2 of these strips, that would be 2/10. Or of course I could do it the way I did it when I started, and that would be there are 20 of these little pieces out of 100 altogether. So these are all equivalent. They have the same value. I'm now going to show this on a number line. When we look at a number line, we can write this down as a fraction or as a decimal. Our 0 starts right here. And as we can see right here, here's our 0.1. 0.1 is one way to say it, or we can call it 1/10. If you think of our place value for a minute, this is the ones column, this is the tenths column. So we can write it as 1/10, like that. Our 1/10 is labeled, so having one more tenth would mean then we have 2/10. And we can keep labeling these down the line. This is 3/10, and down we go all the way down the line. We could label here, for example, 10/10, because I've counted 10 of these pieces out of 10 altogether. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/10 altogether. And that would be our 10/10, or our 1 as it's labeled here. As we move to the right of our 1.0, we still count in the same way. So this number right here, for instance, we have a 1, a full whole 1 here, and 2/10. So 2/10 we can write like that. That would be one way of saying 1.2, or 1 and 2/10. These are equivalent. We also have the option of writing this as an improper fraction. Right now it's a mixed fraction because it has a 1 whole and 2/10. So the fraction is mixed. However, each one of these distances here is known as a tenth. So if we add all of the distances up from the 0 all the way to the 1.2, we would count 12 of these little distances. So another way of saying this would be 12 over 10. And this is in improper form. And these are the different ways of showing the fraction and decimal equivalents. We're now going to have a bit of practice with this. So here we have our 3/5. So we can show our 3/5 in different ways. If we started off with our fraction strips here, we can start off with our 3/5 right here. I'm circling it. Here's our 3/5, but we want to write it as a fraction. And you saw from the number line, it's very easy to write as a fraction when you have everything in tenths. So we're going to drop a line right here. And the same way of writing 3/5 would be having this many tenths. So 1, 2, 3, 4, 5, 6 tenths. That's if we wrote it like this. So that's 6 tenths. By using the 3/5 on this fraction pyramid, we can rewrite it as 6 tenths. And we can also write it on our grid here with our 100 grid. Our 6 tenths would be if we cut this up into 10 total pieces. That's our denominator of 6 tenths. Like that, our denominator. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we filled in 6 of these. So there's 1, 2, 3, 4, 5, 6. So we have our 6 tenths, or in other words, we can call this 60 over 100, like that. But we can also look at this as 3/5. which is what we started off with, because if we decided to make 5 exact groups like this, we just made exactly 5 groups, and 3 of them have been filled in. So these pieces here, 1, 2, and 3, that's where our 3/5 come in. Let's do another one. 1/2. We have here our 1/2. So if we show 1/2 right there, 1/2, and we drop the line into our tenths right here, we could see it's 1, 2, 3, 4, 5 of our tenths, and we can show this on a line down here. So 1/2 or 5/10, which would be right there, but this makes sense in a different way too. If we made a semicircle from here to here and a semicircle from here to here, we notice that we have exactly 2 pieces that are exactly the same size. So this would be one of those 2 pieces, in other words, 1/2. And that's how we can show that. Here we have our 7/10. Let's show 7/10. So if we look at 7/10 right here, 7/10, I'm circling 7/10 now. And 7/10, we are in this way writing it as a fraction, but over here it's written as a decimal. So if we look at our 7/10 and we look down here, it's exactly the way it's said, the way we say it. So if we look at this one, 7 of these 10th pieces, we can write like this, or we can write it the way we say it, 0.7, and it would be written like that, or 7/10. We can also use our screen here. If one of these lines is a 10th, then we can count 7 of them. So 1, 2, 3, 4, 5, 6, 7. Everything above here is another way of saying 7/10. We can say 7/10 or 70/100, like that. And because these are equivalent, we did them at the same time. And here's 3/10, and we can use this one right here, starting off with our 3/10 here. That's what it looks like as a fraction pyramid. Or we can look at 3/10 right here. Those are equivalent. If 1/10 is here, 2/10 here, 3/10 here, then they're all equivalent. Thank you.